Logarithms.
Logarithms what?
Logarithms.
And indices. Na logarithms zingine tulikuwa tunafanya zinakuja zinaform quadratic equation.
Bado ziko.
Who discovered maths, by the way?
Maths?
Maths. Mathematics. Who is the father of mathematics?
It is me.
Albert Einstein.
I'm the one.
You're the one.
Ancient scholars from Egypt.
And Egypt is a spirit. Ndio bwana.
Hello. We'll continue with what you are doing yesterday. Yesterday we learned on we studied logarithms, and today I want us to do now some questions on applications of logarithm based on what we did yesterday. Jana kwa ile kazi ambayo tulikuwa tunafanya, you realized that kuna mahali tungefika because we could not rush things, and it is so bad sometimes to rush, then you end up not understanding. So let us do it now. Logarithms. Today being date 3rd of June 2026. So there are some few questions I want us to learn. We are going to solve some few problems here. Then when we solve these problems, we may introduce ourselves to further logarithms in form 3. So this lesson is not just doing so further logarithms. So let us get to logarithms. There is a question that we have here, and this question reads, use logarithms correct to 2 to 4 decimal places. Use logarithm correct to 4 decimal places. Hence evaluate cube root cube root of 83.46 multiplied by 0.0054 over 1.56 squared. 1.56 squared. 1.56 squared. That is what we are going to do now. So in this question, quickly we will get to logarithm. So we have number, we have standard form, and we have logarithms. So our first number is 83.46. When this number is written in standard form, it will be 8.346 times 10 to power 1, and in logarithm it will be 1 point. In logarithm it will be 1 point. So we take our mathematical table, we check 8.34 logarithm of numbers to base 10. 8.34, it will be 8.34, it will be 9212. 8.34, then we add 6 at the end. At the column of 6 we will add 3. We will add 3 and we have 5, 1, 2, 9. So it is going to be 9215. Then we proceed to the second number, 0.0054. If we write this number in standard form, it will be 5.4 times 10 to power 1, 2, 3 to power negative 3. So if this is to power negative 3, it is going to be bar 3 point 5.4. 5.4 is 0.7324. 7324. After that, we can now add our numerator. And when we add our numerator, we will get 5 plus 4 is 9. 1 plus 2 is 3. 2 plus 3 is 5. 9 plus 7 is equal to 16. So it will be 6 carry 1. So 1 plus negative 3 is negative 2. Negative 2 plus 1 will be equal to negative 1. So the sum of our numerator will be bar 1.6539. We now get to the denominator. Our denominator is 1.56 squared. So if we are to square this, it is going to be standard form. It is 1.56 times 10 to power 0. And the logarithm of this is going to be 0. We get back to our logarithm to base 10 and check out on 1.56. 1.56. It will be 1031. 1.56, it will be 1031. And because we are raising to power 2, if we are getting the logarithm as this one to power 2, it means we will now multiply this by 2. We will multiply it by 2. And when you multiply that by 2, if it was to power 3, we would have multiplied the logarithm by 3. So if we multiply by 2, it will be 0.1031 times 2. It will be 1 times 2 is 2, 3 times 2 is 6, 0 times 2 is 0, 1 times 2 is 2, and a decimal, then a 0. So it is going to be, when you multiply by 2, it will be 0.2062. That is the denominator. So when we get that as the denominator, we are now going to take the logarithm of the numerator, we subtract that one of the denominator. We will take the one for the numerator minus the one for the denominator. So we have number, we have standard form, we have logarithms. So on the side of logarithm, we have bar 1.6539, and we are going to subtract 0.2062. Don't forget we are finding the cube root. So when we subtract what we are going to get is 9 minus 2 is 7. 3 minus 6, it cannot be done. So we will borrow 1 from 5, we remain with 4. We have a 13. 13 minus 6 is 7. 4 minus 0 is 4. 6 minus 2 is 4. Then negative 1 minus 0 is negative 1. So that is what we have. And now we are supposed to find the cube root of negative 1 or bar 1.4477. Remember, this is what we said. We said that if our final value here is a negative, we split it into two. We split it, number one, into characteristic, and we split it into the decimal part, which we call the mantissa. We have the characteristic and the mantissa. So what we are going to do, if we split this, it will be negative 1 or bar 1 plus 0.4477. 0.4477. Then we draw our number line. And since we are determining the cube root, we are going to write numbers from 0, negative 1, negative 2, negative 3. Then towards the front, 1, 2, 3. Towards the right, that is. So if we have that as our number line, our number is at negative 1. What is the least number that we can add to negative 1 to get a number divisible by 3? The closest is negative 3. What are we going to add to get negative 3? We are going to add negative 2 so that we can get to negative 3. So we have added negative 2 to come to negative 3. So that is going to be bar 3. Plus, if we added negative 2 to get to negative 3, then that simply means that the other side we will now take negative 2 as positive, and it will be 2.4477. We will have that bar 3 plus 2.4477. And when we get that, we are going to divide both sides by 3. Both sides by 3. And when we divide both sides by 3, we are going to get negative 3 or bar 3 divided by 3 will be equal to bar 1 plus, if we divide this one by 3, we will get by 3 1 by 3, it will be 0.8 because of 2.4. Then this will go 1 time because of 3. Then 1, 17. It will go 5 because of 15. Then we are left with 2, it will go 9. So it will be bar 1 plus 0.8159. So if we take bar 1 plus 0.8159, it is going to give us bar 1.8159. When we get this, we can now take it back to this column, and we will have times 10 to power negative 1, and we are going to determine the anti-logarithm. So here we will find the anti-logarithm of 0.8159. 0.8159. After we get this as our antilog, we can now proceed to the table of antilogarithms. The table of antilogarithms, and determine 0.815. It is 6.531. 6.531. That is 0.815. Then we add the last column of 9. Last column of 9, we will add 14. We will add 14. 4 plus 1 is 5. 3 plus 1 is 4. 5. Then a decimal, then a 6. That will be times 10 to power negative 1. Times 10 to power negative 1. So we can now write this number as a normal number. 6.545 times 10 to power negative 1 is going to give us 0.6545. 0.6545. Logarithm of 1.56. Logarithm of 1.5. check out on I think it should be 0. Or someone is saying logarithm of 1.56 is 0.1931. Please confirm that one for me, because my mathematical table, I think probably it is wrong. It is saying it is 1031. 1031. Let me then not trust this. It also depends with mine is field edition. It might have an error, but you can do that. You can redo that again and check out where the error is coming from. But that is the way. That is how we go about it. 0.6545. 0.6545. 0.6545. 0.6545. 0.6545. Yes, that logarithm must be wrong. My logarithm here is wrong. So go with the right logarithm. Sorry for that. My table has an error. My table has an error. The mathematical table has an error. Let us do another example. Use logarithms correct to 4 significant figures to evaluate. Use logarithms correct to 4 significant figures to evaluate. Cube root of square root of 72.56 times 0.64 over 1.845 squared. 1.845 squared. Let us do that one. You can correct on that mistake using the correct value. So we have number, we have standard form, and we have logarithms. So our number is 72.56. Our standard form is 7.256 times 10 to power 1. And our logarithm is 1 point. So let us get to our tables. 7.25. 7.25. 7.25, it is 8603. 8603 plus 7.25 6 plus 4. 3 plus 4 is 7068. So it will be 8607. Then we have the second one, 0.64, which will be standard form 6.4 times 10 to power negative 1. And this one will be bar 1 point. Logarithm of 6.40, it is 8062. 8062. And because it is multiplication, we will have, and when we add, 7 plus 2 is 9. 0 plus 6 is 6. 6 plus 0 is 6. 8 plus 8 is 16 carry 1. 1 plus minus 1 is the same as 1 minus 1, which is equal to 0. 0 plus 1 is 1. And by doing that, you are awarded 1 mark. Let's get to the denominator, 1.845 squared. This number in standard form, it will be 1.845 times 10 to power 0. So this one will be 0 point. Back to the logarithm table, 1.84 2648, 1.84, then 5 at the end, we will add 12, 0 carry 1, it will be 6, 6, 2, so it will be 2, 6, 6. That is the number. Let's also put that 0. Then because there is a power 2 here, we are going to multiply by 2. We will multiply by 2. And when we multiply by 2, what are we going to get? Zero times 2 is 0. 6 times 2 is 12 carry 1. 6 times 2 is 12 plus 1 is 13. 2 times 2 is 4 plus 1 is 5. A decimal, 0 times 2 is 0. So that is going to be 0.5320. That is the denominator. So between the numerator and the denominator, we are supposed to subtract. And remember, we are finding the square root. We are supposed to subtract, and you know we are finding the square root. So it is number, standard form, then logarithm. So our numerator is 1.6669 minus 0.5320. We are going to subtract. Nine minus 0 is 9. 6 minus 2 is 4. 6 minus 3 is 3. 6 minus 5 is 1. Then 1 minus 0 is 1. So, because this one is positive, we said that if it is positive here ina kazi nyingi, we will just divide by 2. Remember, we are finding the square root, we'll just divide by 2. So 1.1349, we'll just divide by 2. And when you divide by 2, you are going to get, this will give you 0.5 because of 1.0. Then we remainder 1, it will go 6 times because of 12. Remainder 1, it will go 7 because of 14. And it will go 4 because of 8. Then 1, it will go 5. So if we round off this to the nearest 4 significant figures, it will be 0.5675. So that is what we have in logarithm form. Hatujamaliza? In logarithm form. So this one, we now take it this side. It will be times 10 to power 0, so that we can find the antilog. So we will come and determine the antilog of 5675. And the antilog of 5675, the antilog of 0.567 is 3.690. 5, we will add 4, so it will be 496.3. So it will be 3.694 times 10 to power 0. So times 10 to power 0, 10 to power 0 is 1. So that answer will remain as like that, 3.694. 3.694. And we are done. We are done. Let us do the last one. Kamoja tu. We proceed to logarithmic notations. Wacha tufanye moja ili tuingie kwa logarithmic notations. Use logarithms. Cube root of 36.72 times 0.46 squared over 185.4. 4 marks. Haya, tufanye hili. Let's do this one. So very fast, number, standard form, log. So number is 36.72. Standard form is 3.672 times 10 to power 1. Then logarithm is 1 point. Let's go to 3.672. 3.67 is 5647. 5647. So that is 3.67 ni 5647. Then 2 ya mwisho itakuwa plus 2. So itakuwa 5649. 5649. Then this one will be 0.46 squared. The standard form is going to be 4.6 times 10 to power negative 1. And the logarithm will be bar 1 point. Bar 1 point. The logarithm of 4.6 is 6628. 6628. Then remember we are multiplying by 2. So this one will be multiplied by 2. So we can go tunaweza enda quarantine kidogo kama watu wa Ebola. Tuifanye kando. Tuifanyie kando. Ikikuwa sawa turudishe. Ito quarantine method. So 8 times 2 is 16. 2 times 2 is 4 plus 1, 5. 6 times 2 is 12, carry 1. 6 times 2 is 12. 12 plus 1 is 13, carry 1. Negative 1 times 2 is negative 2. We have a decimal. Negative 1 times 2 is negative 2. Negative 2 plus 1 is negative 1. So it will be bar 1. So hii yote ukimultiply itakupatia bar 1.3256. Kwanza tugawanye hivyo. Then tunafaa add. So tutachukua 1.5649. We add 6, 5, 2, 3, then bar 1. Then we add. Tukiadd tutapata nini? 9 plus 6 is 15. 5 carry 1. 5 plus 5 is 10. Carry 1. 6 plus 2 is 8 plus 1, 9. 5 plus 3, 8. a decimal. 1 plus minus 1 is 0. So that is the numerator. That is the numerator. Tatupatia mark. Sasa tuende kwa denominator. Denominator ni 185.4. So in standard form it will be 1.854 times 10 to power 2. So it will be 2 tuende kwa 1.8. 1.85. 1.85 itakuwa 2672. 2672. 2672. 1.85 ni 2672. 2672. Then to add 4 ya mwisho. 4 ya mwisho tuna add 10. Obvious. Si itakuwa 2682. So tukuja hapo 2682. Tukifikia hapo tunafaa tu subtract. Juu ni division. Tukisubtract 5 minus 2 is 3. Then let us borrow 1 from 9. Itabaki 8. 10. 10 minus 8 is 2. 8 minus 6. 8 minus 6 is 2. 8 minus 2 is 6. Then a decimal. Then 0 minus 2 is negative 2. 0 minus 2 is negative 2. We get our second mark. 0 minus 2 is negative 2. You get your second mark. So hilo swali linasema tutafute cube root. Number, standard form, logarithm. So tuko na bar 2.6223. Hii ni negative. Kama ni negative tulisema tuna split mara mbili. We have the characteristic bar 2, then we have the mantissa 0.6223. Tukichora hivyo tunakuja tunachora number line. Tunasema from 0, negative 1, negative 2, negative 3, 1, 2 and 3. Haya, tuko hapa. The smallest number we can add to give us a number divisible by 3 is negative 1. So it will only take an addition of negative 1. It will only take an addition of negative 1. It will only take an addition of negative 1. Itupatie nini? Negative 3. So itakuwa bar 3 plus, kama ni negative 1 hapa itakuwa 1. 1.6223. Na juu tunataka cube root, tutadivide by 3. Tutadivide by 3. So ukidivide hapa by 3 itakuwa bar 1 plus, hii ukidivide by 3 itakuwa 0.5 juu ya 1.5. Ibaki 1. Ikuwe 1 times 4. 3 times 4 iwe ni 12. Then 2. 2 haina kitu inaweza ingia na so tutaweka 0 ili iwe 23. 23 itaenda by 7 because of 21. 21 ibaki 2 iwe recurring. So iwe inajirudia 6. So itakuwa 0.5408. Ikikuwa hivyo tuki add itakuwa bar 1.5408. Tulete huku ikuwe times 10 to power negative 1 na tunataka kutafuta antilog. So tutatafuta antilog of 0.5408. Antilog of 0.5408. And when we do that, ukienda kwa mathematical table utafute antilog ya 0.540 utapata 3.467, then 8. 8 huko mwisho uta add 6. 7 plus 6 is 13. 6 plus 1 is 7. 4, 3. So itakuwa 3.473 times 10 to power negative 1. So hii decimal tutairudisha wapi? Nyuma. Ikue 0.3473. 0.3473. And that is how we find the square roots and the cube roots of numbers using logarithm. If you have a question, you can ask. Anyone with a question? Anyone with a question? Then, if none of you have a question, then from that PDF that I sent you, you can continue attempting these questions on logarithms. You can continue to attempt these questions in logarithms. Let's combine them. Further logarithms. Further logarithms. So we have got different rows of logarithms that we really need to understand. That logarithm of A plus logarithm of B is equal to logarithm multiplied by AB. When we talk of logarithm of A, we mean base 10 or any base. It is not a must it be base 10, but it can be any base. So logarithm of A to base 10 and logarithm to base 10 B is equal to logarithm to base 10 A times B. That is the first row, very important. So what does that mean? That means if you have a number like logarithm to base 10 4 plus logarithm to base 10 2, it is going to be logarithm to base 10 4 times 2. And once you have that, it is going to be logarithm to base 10 8. Logarithm to base 10 8. Logarithm to base 10 8. That's just a rough example that we are doing. Let us have our second row. Our second row states that logarithm to base 10a minus logarithm to base 10b is equal to logarithm to base 10 a over b. A over b. You can note the difference. There is not that a big difference between these and the rows of indices. It is one but the same time. When we were dividing, we were subtracting. It is one but the same thing. So, logarithm to base 10 10 minus logarithm to base 10 5 is going to be logarithm to base 10 10 divided by 5. And once we do that, logarithm to base 10 will be equal to 2. That's just another example. Note them down very quickly. Logarithm to base 10 2. So, another law of logarithm is that logarithm to base logarithm to base a b to power n, logarithm to base a then b to power n is the same as n logarithm of a b, is the same as n, that is multiplication, logarithm to base a b. So we just take this back here. Hii power imerudi nyuma ikakuwa hivyo. So what does that mean? That means if we have a number like logarithm to base 10 3 squared, it is the same as saying 2 logarithm to base 10 3. 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 So when we do that, we can do some few questions. Solve the equation. Two log 15 minus log x is equal to log 5 plus log x minus 4. You have that 2 log 15 minus log x is equals to log 5 plus log x minus 4. So if you check this one clearly, so even if it is not written, it is always, this one is to base 10. Kama ijaandiko inakuanga to base 10 unless imeandikwa 2 3 hivyo. Lakini kama ijaandikwa ni kumaanisha it is to base 10. So in such, what we are going to do is that hii tumesema law yake ni gani? Hii tumesema tunailetanga hapa juu inakuwa power. So itakuwa log to base log 15 squared minus log x is the same, is equal to log 5 plus log x minus 4. So ikiwa hivyo, hii mahali kuna subtraction inamaanisha nini? Remember tumesema log A minus log B is equal to log A of B. Kwa hivyo hii yote log 15 squared minus log 8 ni the same na log 15 squared over 8. Nayo ile ingine the other side tulisema log A plus log B inafaa iwe log AB, tuna multiply. Kwa hivyo log 5 plus log 8 minus 4 inafaa iwe log, tuchukue nini, 5 into bracket 8 minus 4, tuna multiply. So tuko na haya mbili. So itakuwa tutachukua hii log 15 squared over 8 is equals to log 5 8 minus 4. Tukiwa na hiyo, ukifika hapo you can just drop the logs. Drop the logs. Unaachana na logs, una solve bila logs. Una solve bila logs. Ukisolve bila logs itakuwa 15 squared is 225 over 8 is equals to 5 into bracket 8 minus 4. So itakuwa 225 over 8 is equals to 5 times 8 is 5 minus 20. That is over 1. So tukifika hapo we can cross multiply to have 8 into bracket 5 minus 20 is equal to 1 times 225 is 225. Na tukifika hapo 5 times 8, 8 times 5 is 5 squared minus 20 times 8 is minus 28. Then tuleta hii na huku itakuwa minus 225 is equals to 0. We can divide every side, everything by 5. And once we divide by 5, we will get 8 squared minus 4 minus 225 divided by 5 will be 49. If I'm not wrong. No, it will be 45. Is equal to 0. Then from there you can solve for 8. Can you be able to solve for 8? Solve for 8. Can try and solve for 8. And when we solve for 8, we can have our A is 1, our B is negative 4, and our C is negative 45. So 8 is equal to minus B plus or minus B squared minus 4AC over 2a. So our x is going to be minus b is minus 4 is 4, plus or minus b squared is negative 4 squared will be 16. Then minus 4ac will be a times 1 times negative 45 is negative 45. Then negative 45 times negative 4, that will be equal to 180 plus 180 over 2 times 1 is 2. 2 times 1 is 2. And by doing so, we have our x is 4 plus or minus 16 plus 180 is 196. Square root of 196 is 14 divided by 2. So our x will be equal to 14 plus 4 is 18 divided by 2, or x is 4 minus 14 is negative 10 divided by 2. So our x is either 9 or our x is negative 5. So we will get that those two as our values of x. We will get those values of x. Solve the equation. This is another question assessed in KCSE. 2 log x minus log into bracket x minus 2 is equals to 2 log 3. We have that one. Two log x minus log x minus 2 is equal to 2 log 3. So with having the rows in mind, you ought to know that log 2 log x is the same as log x squared minus log x minus 2 is equals to log 3 squared. So hiyo bado ni kusema hii, ukiona division tulisema unajua ni ku minus, unajua ni ku divide. So itakuwa log into bracket x squared over x minus 2 is equals to log 3 squared is 9. So once we have that, we can drop the logs. Tukidrop logs tutakuwa na x squared over x minus 2 is equals to 9 over 1. X squared over x minus 2 is equals to 9. Ikifika hapo you cross multiply. X squared times 1 is x squared is equals to 9 times x minus 2. So when we open our brackets, we will get x squared is equals to 9x minus 18. That also has formed a quadratic equation. It has formed a quadratic equation. That is just by coincidence. Si kusema zote zinafaa ziform quadratic. So x squared is equal to 9x minus 18. Tutazileta na huku ikue x squared minus 9x plus 18 is equal to 0. So here our a is 1, our b is negative 9, and our c is 18. So x is minus b plus or minus b squared minus 4ac over 2a. So our x is equal to minus b itakuwa minus 9, which is 9, plus or minus 9 squared is 81. Then 4 times 1 is 4, times 18 is 72. So it will be minus 72 over 2a. 2 times 1 is 2. So our x is equal to 9 plus or minus 81 minus 72 is 9. Square root of 9 is 3. Then divide by 2. So our x will be equal to 9 plus 3 is 12. 12 divided by 2 is 6. Or our x will be 9 minus 3 is 6. Divided by 2 is 3. So our x is either 6 or our x is equal to 3. So generally that is how we approach logarithmic notations. There are still more and more that we have not approached. Kuna zingine hatuja approach. So I want you to solve this one. Solve the equation. Logarithm of 10 plus logarithm of 2x minus 9 is equals to logarithm of 3x plus 5 minus logarithm of 2. 3 marks. Fanya hiyo. Do that one. Have you? Solve it quickly. The addition row. The addition row. So if that is the addition row, we said it is logarithm 10 into bracket 2x minus 9. That is what we said. Is equals to. We are going straight to the point. The division row. Logarithm of 3x plus 5 divided by 2. Si lazima ushinde ukiandika hizo maformulas. So logarithm 10 times 2x itakuwa 28 minus 10 times 9 is 90 is equal to logarithm of 3x plus 5 divided by 2. Kufikia hapo, you can drop the logs. Listen, you don't cancel the logs. You don't cancel the logs. You drop the logs. You drop the logs. Even if you are not going to write drop the logs, just leave them. Leave them. We achana nazo. Usicancel. Hata usiandike. We unaachana tu nazo. Unachukua 28 minus 90 is equals to 3x plus 5 over 2. Then you can start having fun and joke with numbers. Just joke with numbers. How do you joke with the numbers? Over 1, you cross multiply. 2, we multiply here. It will be 2 times 28 minus 90 is equals to 3x plus 5. Ukifanya hivyo 2 times 28 ni 48 minus 2 times 90 ni 180 is equal to 3x plus 5. Then we put our like terms together. Leta hii side moja. 48 minus 3x itakuwa 37x is equals to, chukue hii tupeleke the other side, itakuwa 5 plus 180 itakuwa 185. Chukua 185 udivide na 37, utapata nini? Utapata 5. So x yetu itakuwa 5 na tumemaliza. And we are done. As simple as that. Joking with numbers A, B, C, and D. Haya. Solve this one. Nothing. Given that two log x squared plus log of square root of x is equals to k log x. Find the value of k. Attempt that one. Are you done? Let's do it together. So 2 log x squared plus log of the square root of x is the same is equal to log k log x. So don't forget the law of logarithm. Hii tulisema hii power inarudingi juu. So this is the same as saying log x squared plus log x square root of x is the same as x to power half is equal to logarithm of x to power k. So hii itakuwa logarithm of x 2 squared is 4 plus logarithm of x to power a half is equal to logarithm of x to power k. So we have our, you see our bases. Our bases are the same. So we just drop our bases down. And when we drop our bases down, we are going to have 4 plus a half is equals to k. And that will give us k is equal to 4 and a half. K will be equal to 4 and a half. And we are done. We are done. Done. Mathematics, mathematics, mathematics. It's as simple as joking with numbers. Mathematics, how I love you. Mathematics, yeah. Haya. I want to wish you a good evening, a good night, that is. Let us meet tomorrow. We are not yet done with logarithmic notations. We won't also have to work on index notation. How do we find or like numbers in index notation? Index is the same as power form, but this we are not going to spend time doing this. Here to spend time kuifanya in class. I'm going to do some short skits videos and I'm going to send the links to you, or you can just access them from my YouTube channel and watch them so that we can now do the rest. Have a blessed night. It has been a blessing having you guys on board, and we are slowly eroding the work that we are supposed to do in mathematics paper 1. Bado tunaendelea kuerode and we are close to finishing, na kila kitu itakuwa poa. Have a good evening, have a good night.